Good afternoon. My name is Frank Olivier. I'm here this afternoon to talk to you guys about WebGL. I'm a program manager in the Internet Explorer team. I've been working on Internet Explorer since IE 9, since we started doing hardware acceleration. And we've been rendering your content, your HTML5, your CSS, your JavaScript on the GPU on your behalf for the past couple of years. And now with WebGL, you get to be closer to the GPU. So we're taking a step aside, and you're getting closer to the GPU. So let's take a little look at WebGL. It's a dramatic step forward in the capabilities of the web platform. I'm going to show a couple of demos here. This is one of my favorites. This is a little 3D voxel world, and you can spend all day flying around. But there's no building things yet, unfortunately. Another nice one is a very nice 3JS physics demo. Very, very cool demo that shows you stuff you can't really do with anything else in the web platform. If you're a really, really, really good JavaScript developer, there are some pretty impressive photorealistic WebGL pages you can create. That looks pretty amazing. And all this is just running. You can see up there in the address bar running inside of IE. So we've been taking a look at WebGL on the web. We've also been talking to some people internally in Microsoft that have also been looking at WebGL. I want to share a little preview of Photosynth 2. This is a hike in Utah where you can hike through a canyon. And this is a preview of Photosynth 2, where you can take your own photos, upload them to a web service, and Photosynth 2 just stitches them all together for you and interpolates the 3D in between the scenes that you photographed. So very nice, very awesome way to look at your photos. So as you can see, WebGL is a really, 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 really big step forward in the web platform. We're very excited to have this inside of IE 11. In this talk, we'll go over how and when to use WebGL. I'm assuming that there's kind of two audiences here. I'm assuming there's people that know WebGL or that know 3D programming and want to hear more about what we did in IE 11. And then I'm assuming that there's people here who are good JavaScript developers who don't have much WebGL experience. I'm going to do what I can to get you up to speed on writing your first WebGL app. We'll talk a little bit about how we implemented WebGL in IE 11. We'd love for you to know more about what we're doing under the covers to make sure that your WebGL runs safely and securely. And then lastly, we'll talk about best practices. We spent a huge amount of time looking at all the WebGL websites out there on the web. I have a team of very, very good people looking at all the common coding patterns out there on WebGL content. And there's some good coding patterns and some bad coding patterns that we'd like to talk to you guys about. I'll leave some time at the end for questions, and also I'll stick around at the end if you want to ask some more questions. But throughout this entire WebGL project, we would definitely want to hear feedback from you, the developers, on what you want to see inside of the WebGL renderer. So let's talk a little bit more about what WebGL is. If you have lots of background in 3D programming, the easiest way to explain WebGL is that it's a new binding for the 3D APIs that you know. So it's a immediate mode JavaScript API that just allows you access to the GPU. If you're a more typical web developer, the easiest way to start to explain WebGL is that it's like 2D canvas, but it's pretty low level compared to what you have in 2D canvas. There's lots of housekeeping you have to do yourself to really use the technology well. It has a much steeper learning curve than Canvas 2D does. Canvas 2D has pretty obvious methods that you call. 3D programming is a bit more complex with matrix and vector math and linear algebra. The good news, though, is that WebGL has vastly improved performance potential. Depending on what you're doing, you can actually run code much faster that you write yourself on the GPU. Another important thing that I want to get across is that thinking of WebGL as just a 3D programming API is really the wrong way to approach it. The power of WebGL is that you get to control and program the GPU yourself. That's a very low-level functionality. It's a very tricky thing to go and exploit. But it's really the best way for you to, in some scenarios, make sure that you run code really, really, really fast. The power of WebGL really is that you can program each pixel in your own canvas. And that's something you don't really have with any other web technology. So with that, let's do a quick demo on how WebGL and GPUs work. So this will probably be the world's quickest WebGL tutorial. This isn't anybody in the IE team. I couldn't get any volunteers for this. But this is some stock photos that I bought off of a stock photo site. This is a little photo warping demo that I wrote, and you can use WebGL to go and manipulate the photo. And again, this isn't anybody in the IE team, but that's how broadly I was smiling when we got WebGL working in IE 11. So let's talk a little bit about what's going on behind the scenes here. So what's happening here is that I'm uploading a big triangle mesh, a buffer, up onto the GPU. I also upload my photo, and then I just paint my photo onto the mesh. That's pretty standard so far. The thing that I'm doing in my program here is that as I manipulate this surface, I upload uniform points up to the GPU. If you're a JavaScript developer, think of uniforms as global variables you set on the GPU. And as I manipulate this mesh, you can see that the triangles all deform. And let's start over again. So you can see all this is happening in real time on the GPU. The only thing that the CPU is doing here is that it's handling some mouse input, and it's uploading a couple of bytes up to the GPU. So really, the CPU in this scenario has nothing to do, really. It's barely ticking over. And then the second step here is to paint that onto the mesh. So the painting, the manipulation and the painting here happens with a vertex shader and a fragment shader. You might have heard these terms before. The vertex shader takes this array of triangle coordinates that I uploaded, the vertices that I uploaded, and it distorts them according to the uniform points that I upload as I manipulate the mesh. So this is really one of the key strengths of WebGL, or of programming the GPU. You have this vastly parallel processor that runs simple programs, but it's a vastly parallel processor that can run your code. And like I showed, you can just do all this manipulation in real time. I think this is about 400 points. And then the second stage here in the pipeline is taking those triangles, converting them into pixels, and then you, again, get to run your code and paint the pixels. So in this case, I just look up a bitmap and go paint the pixel that corresponds to the right triangle. So very simple, very easy. My first WebGL app. Of course, this could have been a 3D app. I could have uploaded a 3D mesh. I could have rotated this in 3D space. The basic concept is the same. You get to run code to manipulate your triangles and paint your triangles, but the concept is exactly the same. Let's move on to GLSL itself. If you're a JavaScript developer, good news and bad news. GLSL is like C, so it's different from JavaScript. If you know C, you're off to a good start. There's no pointers, no recursion, no dynamic memory allocation on the GPU, so it's a bit simpler than C. If you really want to get the most out of WebGL, you're probably going to be writing your own GLSL shaders. It's a bit tricky, but like I said, there's fewer constructs in there for you to really have to use. GPUs are very, very simple processors, so really your programs have to be fairly simple. And then the good news as well is that you have vector matrix and bitmap sampler types in your GLSL syntax. So you can go and use lots of complex math to do your 3D translations, to do your lighting, and your transforms. So GLSL is a little bit hard to learn. There's really no debugger for GLSL when you run it inside of a browser. So it's a little bit tricky to learn, but very worthwhile to pick up. Let's talk a little bit about when to use WebGL. I think it's absolutely the best choice if you have a project that requires you to program the GPU or do very, very fast GPU 3D scenes. That said, though, you should always consider CSS transforms or 2D canvas or SVG. Those are all hardware accelerated in IE, and they have been since IE 9. You can do some very, very complex scenes with much less complex code and run those scenes at 60 FPS. WebGL is a great technology to learn, but you might get bogged down a little bit, so don't jump in immediately on a critical project on WebGL. Perhaps take a look at these technologies as well. Also, DirectX is a very, very good alternative. If you want to build an app, DirectX gives you access to all the capabilities of the hardware, where WebGL, of course, is a smaller, confined set of functionality that's exposed to your web browser environment. And there's very powerful native APIs and native tools that you can use with DirectX apps. So let's talk a little bit about what we created. The preview that you're getting today, we're still working on WebGL, but the most common 3JS and the most common WebGL functionality just works. There's hundreds of sites on the web. You can just run through our browser, and it'll work perfectly. It'll render WebGL perfectly. In case there's any issues, we advise you guys to take a look at the F12 tools. There's going to be a little log in there that shows you any WebGL information. It'll show you, as you're debugging your code, which issues we ran into. We've also been very, very happy in the performance of our WebGL implementation, but we haven't been focusing primarily on perf. So we definitely want to hear from you guys if there's any perf scenario that you want to have even faster. Of course, the other very easy thing is WebGL is on by default on all IE11 devices. We just want to make it simple for you guys. If your user has IE11, he has WebGL. No problem there. On by default, running all the time. And it'll also be available on Windows applications. So if you have any Windows application you're creating that either uses the Windows Web App application framework or just a native web view, that all runs WebGL content just fine. I've got a couple of questions today about the architecture of WebGL in IE11. IE11 is a DirectX 11 application. We take WebGL code and translate that over to DirectX equivalents. Whenever I use the word translate, the next question I get is it slow? And there really isn't any performance degradation in us translating from WebGL into DirectX. It's a very thin layer between WebGL code and the DirectX stack. We take your methods that you call in a DirectX context and the WebGL context, and we translate it over into DirectX equivalents and through the DirectX 11 runtime. And then that goes into the graphics driver, or in some rare cases, in software rendering underneath IE. We run in software rendering mode on server machines or very old laptops or in TS environments. So the vast majority of your users will run WebGL on the GPU. We also take your GLSL programs that you give us, and we translate that over to HLSL, which is the DirectX counterpart equivalent to GLSL. So it's all DirectX underneath IE11. About 2 years ago, we had a blog post on Microsoft Security Research about security issues in WebGL. We're happy to see that things have changed a bit over the next couple of months. One of the first things we're very happy to see is updates in the core section of the spec. If you're loading images into WebGL, if it's on your own domain, it's super simple and easy. It just works. If you're loading images from another domain into WebGL, then you have to have cores enabled on the other domain. So that's a good way to prevent any image theft scenarios from happening. In Canvas 2D, we taint the canvas in this scenario. You can't really do that in WebGL because it's a fully programmable environment. You can't sanitize or taint the canvas in the WebGL case. Also, because WebGL is a really low-level API, there's lots of housekeeping that you have to do when you no longer have a GPU device. So in some cases, if the user suspends and resumes the machine, your GPU goes away and comes back. You have to recreate the GPU context, re-upload all your state onto the GPU, and then resume rendering. So there really wasn't a great way in WebGL to handle that event. On the IE side, we've done lots of work to ensure that we sandbox code. When we run GLSL programs, we take your GLSL code and we completely translate it. There's not one byte of the original GLSL that survives our translation. We all parse it and reconstruct it and create safe, verified HLSL on the other side. So there's really we really want to ensure that the programs they run on the GPU are really, really safe and don't have any potential attack vectors in them. Even with us ensuring that the GPU runs safer programs, there really is no absolute 100% way to ensure that the GPU will not get overloaded by shader programs that you run. Your GPU environment is cooperative multitasking. It's a little bit like way back Windows 3.1 days. You have a bunch of apps running on one system. If one of them misbehaves, then everybody suffers. The GPU is a lot like that. Everybody that uses GPU rendering, or the apps in the system that use GPU rendering, you all have to cooperatively multitask. In the Windows case, though, since Windows Vista, we've been able to tear down a GPU stack and rebuild it if an app misbehaves. That's called GPU recovery. And if you've ever seen this little balloon pop up, that's what that is. If you have a misbehaving DirectX or WebGL app, we can reset the GPU subsystem, and all the DirectX apps, including IE, just recreate all their resources and keep on rendering. We've also taken a big bet on the DirectX 11 runtime. We're running on the absolute latest version of DirectX. Other implementations of WebGL on Windows use older versions of DirectX. There's lots of additional security checks that we get from running on the latest runtime. Because we're running on the DirectX 11 runtime, we also get the very, very latest drivers that are on the machine. So that helps us in the security area as well. But even then still, we're very concerned with security in the IE team. We've even gone to the extreme of doing GPU source code driver audits on some devices to ensure that no security issues remain at any point in the stack. So we spend a huge amount of time focusing on security first and foremost, running through every possible attack scenario we can think of to ensure that your code runs safely and reliably on the machine. Now, you as a developer don't have to do anything different. We sandbox all this on your behalf. But we really want WebGL to be a safe, dependable, stable web standard. And then, of course, as before in previous versions of IE, we have a very good software rendering stack. In case there are issues with your GPU, we can revert you back to software rendering. We have a web service with a list of all the GPU device IDs out there that have issues. And we can, in a couple of hours, revert back to software rendering if need be on some class of devices. So we actively monitor all the thousands of Windows devices, thousands of different kinds of Windows devices out there, and we revert back to software rendering if needed. Let's change gears just a little bit. Some of my conversations today with the developers here, people have said, this is all great, I love WebGL, but it's a lot of triangles and a lot of GLSL, and can it be easier? And the good news is that yes, that's entirely possible. There's a huge number of frameworks out there that makes WebGL programming a lot easier. In our analysis of all the WebGL content out there, we've seen that roughly half of the WebGL content out there uses the 3JS framework. It's a great framework. It's on version 58 right now, I think. And it makes the entire WebGL programming experience much, much, much simpler. It's a great framework that still allows you to get your own hands dirty with your own shaders if you like. So with that, let's do a quick demo. You guys saw this earlier today. This is an example of a cube map. In this case, we have a camera sitting inside a cube in 3D space, and we load some bitmap resources on the cube and then spin it around. And that's the demo in real life. And you can see just much. There we go. So the 3JS code for doing this looks much, much, much simpler than what we have on the direct native programming side. You can set up a renderer, you can set up a scene, you can create a mesh, apply that to your scene, and then create a camera. So the setup that you do inside your WebGL application is much simpler than creating your own buffers, creating your own vertex coordinates. WebGL takes care of, 3JS takes care of all that housekeeping for you. Most WebGL applications have a setup component and then a rendering loop. Again, the rendering loop part of a 3JS application is much, much, much simpler. In my case, on that cube map demo, I just have some simple math that computes a little vector in 3D space that the camera should look at. So now, if you're writing the equivalent WebGL code to do this yourself, you'll be doing a bunch of matrix math or doing your own vector math. 3JS makes it much, much, much simpler. If you're very interested in getting started with 3JS or WebGL, I'd advise you to work through some tutorials, maybe start on the 3JS side and go back and forth between writing your own WebGL and using 3JS. And then as we've looked at WebGL content out there, we've noticed an interesting pattern on a lot of WebGL content. We've noticed that a lot of WebGL content is written and tested only on your desktop or laptop form factors, and they don't run as well or as reliably on smaller form factor devices. Because you are writing to the GPU, and mobile GPUs are different from desktop GPUs, you really have to adapt your code and run more complex scenes, perhaps, on other devices. So probably the most important advice I can give today is if you are writing your own WebGL code, please do test on a range of devices, all the way from your powerful desktop machines, all the way down to smaller devices with less complex GPUs. We've really seen that this is one of the bigger issues than with WebGL right now, where a lot of code just doesn't run across the board on all devices. It's especially tricky if your device doesn't have a keyboard. We've seen lots of WebGL code or WebGL apps where there's no touch or touch input that's being handled. To help with that, we very much advise you do feature detection. We've seen lots of cases where people try and compile some shaders and upload them to the GPU, and it just doesn't work because the shader is too complex for a tablet class device. So please ensure that you check the compilation status of your shaders before you upload them. The same goes for extensions. We've seen lots of cases where people use extensions and just assume that they're present. That's not always the case. On tablet class devices, you might not have all the extensions available. There's also lots of interesting image formats and coordinate formats that you can give WebGL. We've seen that consistently across all devices, the simpler, most common formats work best. So we'd advise you to just stick to pre-multiplied 32-bit per pixel images and floating point vertices. Just doing anything more exotic leads to some issues running across a variety of devices. Another thing we've seen is that drawing points and lines instead of triangles, that might lead you to some other issues. There are some devices out there that do not support rendering points or lines with more than one pixel width. You can actually check that with a get parameter call on your WebGL context. And you get this array back with an upper and lower bound. And there are still a fair number of devices out there where the range of line widths that you can draw is 1-to-1, 1 pixel wide, or the same for point sizes. So if you're writing an app that needs to do a lot of line drawing or point drawing, you might want to think about either doing that as a progressive, doing thicker lines as a progressive enhancement feature, or doing it as doing the 3D, the triangle setup for that yourself. Another common issue we've seen is that a lot of tablet class devices don't support vertex texturing. So in that vertex shader, you can't always fetch a bitmap and go look up data from that. We've seen this as a pretty common issue across code out there. So please have a fallback plan in case the device that you're running on doesn't support vertex texturing. Also, texture sizes is another one. You might not have support for huge texture sizes. Please be aware of that. You can, again, use the get parameter function to go and see what your size range is. Some frameworks like 3JS actually take care of this for you. So in my example, where I take a look at a cube, if I have a smaller device with a smaller memory footprint, 3JS actually converts onto a smaller cube map on my behalf. Then lastly, we've seen some other interesting patterns. Please use request animation frame. That'll give you a nice steady paint beat to go and paint on. Please avoid background rendering. We've seen lots of cases where people just paint at 60 FPS even though their app is no longer doing anything in the foreground. And then please avoid unnecessary rendering. We've actually seen a lot of pages that do this where, depending on what your scene is, if you're walking around a 3D maze, for example, if your camera is completely stationary, we still see cases where the page just paints in 60 FPS, the same pixels over and over and over and over again. And of course, that doesn't do good things for your battery life. So please only render on demand, only render through request animation frame. That helps you prevent overpaints. We've also seen some cases where content doesn't handle resizes and zoom. That's a pretty easy thing to do. You have the similar problem in Canvas 2D context. You're responsible as a developer for handling all the zoom changes and the window resizes that the user does. And then context loss is another big important one. Depending on which device you're running on, you definitely will see some context loss events. So if I have a laptop with a high power GPU and a low power GPU for when I'm on battery, you'll see cases where the high power GPU goes away and you have to recreate all your resources on the low power GPU. So your user will have a pretty shoddy experience if he unplugs his machine and your WebGL app just doesn't come back afterwards. There's also other cases where you lose the context. Windows Update might be pushing down a new GPU driver for you. Somebody might be doing a terminal server connection to your machine. So this is absolutely critical if you handle the context loss event. And another important one is please, in your rendering loop, spend some time with the F12 tools and optimize your rendering loop. We've seen lots of cases where people do interesting things like update the DOM to do an FPS counter up in the top left corner. And you can see they're getting kind of frustrated with their code comments as to why things aren't going faster. So in your rendering loop, stay away from the DOM, just do WebGL calls. The F12 profiling tools will really help you figure out where the performance bottleneck is. And then lastly, some related talks. There's a couple of good talks here on runtime performance and using the F12 tools. If you're writing a huge WebGL app, you'll definitely be spending some time in the F12 tools to go and debug that app. There's also some really good DirectX talks on writing and debugging DirectX code. If you're interested in the DirectX side of things, please do go check those out. And then to get you on your way, there's a couple of really good resources on WebGL. The learningwebgl.com website is a fantastic way to learn WebGL. That's actually how IE11 learned to do WebGL. There's about 15 lessons on this website that takes you from drawing your first little triangle all the way up to doing nice 3D planets. And that's exactly how we started doing WebGL on IE. We just took the first lesson, made IE run that, and moved on to all the different lessons. So you can learn WebGL exactly the same way that IE did. If you're interested in 3JS, one of the good resources out there is html5canvastutorials.com. It's a really good one to work through. And then on the IE blog and on MSDN, we'll have lots of resources that'll help you get up to speed on WebGL. And of course, we are very, very, very interested in hearing from you guys. On Twitter, I'm Frank Olivier. And on email, I'm franco@microsoft.com. Please do try out WebGL in IE 11. Please run through any WebGL projects that you're working on, and please send us feedback. We definitely want to hear what you guys want to see in a WebGL renderer. Thanks very much.